Okay. Now we got something called an even function. And I'll give you an example of an even function. We got y is equal to x squared. And if I look at my graph would look like that. That's an example of an even function. If we were to look at a point on a graph, we look at the distance over to the y-axis. Let's say that distance is 2. This distance straight over on the other side to our graph would also be 2. Basically, what it means to be an even function is it's symmetric, and for some reason I just cannot write today. It's symmetric to the y-axis. So it's symmetric to the y-axis. A very easy way to think of it in terms of your graph, if you can take your right side of your graph and flip it, reflect it across the y-axis, and it lands exactly on the left part of the graph, then that means it's an even function. So it flips once. Now it has nothing to do with an x squared. I can give you a problem that has an x squared in it that's not even. So on a test, I always put on there whether a function's even or odd, and I tell you to explain why. The y is symmetric to the y-axis, not because it has an x squared. If you put that down, I'll take every point off, because again, I can give you a different problem with that x squared that isn't. Well, let's take a look at an odd function. Y is equal to x to the third is an odd function. Graph looks like this right here. And what makes it an odd function is the fact that it's symmetric to the origin. Has nothing to do with the odd power. I mean, it has a little bit, but you can't use that as your reasoning, because I could give you a different problem with an x to the third that is not an odd function. So again, it's symmetric to the origin. That's why it's an odd function. Now we're going to really focus. I'll do one of these by hand. I like to show you the steps on why it's by hand, why it works, but we're going to really focus on using the graphing calculator for this. Some of the problems I may put on a test would be really hideous by hand, but very easy on a calculator, and the calculator makes it piece cake. Okay, let's look at this one. Determine whether each function is even, odd, or neither. So we got 5. We got f of x is equal to x to the fifth minus x to the third. Well, again, we have to graph it. So let's bring up our graphing calculator. Okay, so I'm going to press y equals. I'm going to press clear to clear out whatever's on y1. I don't have anything, but. And then I got x to the fifth, so I do x caret 5 minus x to the third. So minus x caret 3. And then graph. Okay, now if it's even or not. Well, if we take the right side of our graph and flip it over across the y-axis, this right here, there's nothing for it to land on over here, so it's not even. But it is odd, and I wanted to have an example of an odd one up here to show it. Okay, so this is more or less what a graph looks like. Probably more than less, but okay. To say it's symmetric to the origin, if you take this piece right here, and this should work with any quadrant, not just the first quadrant. If I flip it across the y-axis, it'll look like That right there. If I then flip it across the x-axis, go away fast. If I then flip it across the x-axis, the question is, will it land on this piece down here? And it will. Since it will land on that piece down there, that's why it's odd. Flips twice. Flip it across the y-axis, flip it across the x-axis. We'll look at one more using the calculator, and then I'm going to talk about how to do those by hand. Actually, maybe I'll look at two more, and then I'll talk about how to do them by hand. So I think that this one's neither, I believe. So we got x to the fourth minus x to the third. And again, instructions are to determine whether it's even, odd, or neither. So let's graph this. So press y equals, press clear, x to the fourth, so x caret 4 minus x caret 3, and then graph. Now this is close to being even, but if you look at the distance from the right side of my graph to the y-axis, and then distance from the y-axis to the left part of the graph, you see how it's more. So actually, if I were to take this this right side and flip it across the y-axis, it would not land on that left part of the graph. It would land a little bit further out. So it's not even. It's definitely not odd. If I start with the first quadrant, there's nothing for it to land on down in the third quadrant. So this is a neither. Okay, let's look at one more. I mean, we'll look at more than that, but one more, and then we'll look at some of these by hand. Okay, so we got h of x is equal to 3x squared plus 1. Okay, so let's graph this. So press y equals, press clear. I got 3x squared, so 3x, and then my x squared, plus 1, and then graph. Well, if we take the right side of our graph and flip it across the y-axis, reflect it across that, it will land on the left part of the graph. So that means this is even. Okay, now let's revisit. Actually, I'll do number 7 first. I got h of x is equal to 3x squared plus 1. Okay, to figure out if it's even. Now, we really want these not to have function notation. So let me say y is equal to 3x squared plus 1. We're going to plug negative x in for x and see if we can get the original function. So we'll plug negative x in for x and see if we can get the original function. Okay, so we got y is equal to 3, and then where the x was, I'll put in parentheses. Everything else remains exactly the same. But now I'm going to put negative x in for the x. So I'll put negative x inside the parentheses. Well, negative x times negative x gives us positive x squared. So after we simplify it, we see that we actually do get our original function. That's what tells us this is even. Okay, let's look at a little harder one now. The our first one. So we got y equals x to the fifth minus x to the third, and we want to know whether it's even, odd, or neither. Well, first to check for even, the one we already talked about, we're going to plug negative x in for x. Okay, so we got y is equal to negative x to the fifth minus negative x to the third. Well, negative x to the fifth, a negative to an odd power is always negative, so this gives us negative x to the fifth. And here we got minus, and then a negative x to the third power, again, gives us negative x to the third. So this would become y is equal to negative x to the fifth plus x to the third. Well, the question is, can we get it to look like the original? Well, let me try to factor a negative out. So factor a negative out, and I get x to the fifth minus x to the third. Well, that's close, but we got an extra negative that we cannot get rid of in any way. So it fails. That means it's not even. Well, let's take a look at how to determine if it's odd. So if that one fails, what we do for the odd case is we're going to plug negative x in for x. We'll also plug negative y in for y. And we want to see if we can get it to look like the original function. Okay, so we got y equals, what is our x to the fifth minus x to the third. Okay, and where our variables are, we're going to put in parentheses. Like that. We'll plug negative x in for the x. We'll plug negative y in for the y. And now we want to see if we can, by simplification, get it to look like the original function, this one right here. Well, that's just negative y. We already said that's negative x to the fifth minus negative x to the third. Same reasoning. And then I can factor a negative out, and that gives us x to the fifth minus x to the third. And then I'll divide both sides by negative 1. And I'm going to do that. Those negatives cancel, these negatives are going to cancel, and we're going to end up with y is equal to x to the fifth minus x to the third, which is our original function. That's what would make this algebraically odd. Okay, let's go back to using the calculator. I think we're on this problem right here. So figure that out. And we got f of x is equal x to the seventh minus x. So even, odd, or neither. So let's graph it. So press our y equals, press clear. We got x to the seventh. So I do x caret 7 minus x, and then graph. Okay, definitely not even. I can't take the right side of my graph, flip it across the y-axis, and it lands on the left side. There's nothing for it to land on in my second quadrant. But odd. If I take my first, what's on my first quadrant, flip it across the y-axis, and then flip it across the x-axis, it will land on that piece right there. So this is an odd function. Now these next problems just give you the picture, and you're to tell what's going on with it. It says use possible symmetry to determine whether each graph is the graph of an even function, an odd function, or a function is neither even nor odd. Well, it's definitely not even. If I take this piece right here, it's on my second quadrant, flip it across the y-axis, there's nothing for it to land on in my first quadrant. So it's not even. It is odd though. If I take this piece here, flip it across the y-axis, and flip it across the x-axis, it will land on this part of the graph down here. So number 9 is odd. Number 10. Same instructions. It's not even if I take the right part of my graph here, flip it across the y-axis, there's nothing for it to land on over here. It's not exactly odd, because if I start with the first quadrant, flip it across, and flip it down, it's not going to land exactly on that part down there. So it'll be off. So this is a neither.